I need to thread a few of these, M20 by 1, and I've been thinking for a while how to do this, here on the lathe. Ideally, the thread should come up all the way to this shoulder. But that's not even the problem. The problem is... Wait, let me show you what the problem is. Internally, this is bored to 17.5mm, so the wall gets very thin in this section. And this is right what I need to make the relief for my threading tool. Without this relief, I won't have a window to disengage the tool. And since I don't want to crash the lathe, I know I'll probably disengage too early and end up with a short thread. That's not what I'm looking for. Yeah, just a little bit over 1mm. I guess that relief is not going to happen. I could resolve this by plunging an inverted tool and thread away from the chuck. This could work if I only had to make this one time, but like I said, I have a batch of parts to make and I feel like the plunging, that'll be a bit of hit and miss. It's too easy to dig in too much and destroy the part. The alternative to this is an auto-retracting threading tool, and that's what I'll be making today. This all starts by modifying an existing lathe threading tool on the milling machine. Everything I'll do today will be around this tool, so that in the end, it slides in and out of a tool holder in a controlled way. The first concern to attend is tool height. Since the mechanism will be at the bottom of the tool holder, and it obviously needs to clear both the solid tool post mount and the compound, I have to push the tool up. But by doing so, the threading tool will be then forced to sit above center. So now the compromising starts. If my measurements are correct, I need to skim 1mm off the bottom to bring it back to center height. Let's make it 2mm, just to be on the safe side. By the way, and don't ask me how I know, buying these tools is a bit confusing. You can find the same tool with either a large insert or a smaller one. The 16 at the end of the code means it's the large type, which is the one that can make up to 3mm pitch threads. Metric threads. So let's start by skimming the bottom and machine it flat and square. Now that I know the final dimensions of the tool, I'll start working on the tool holder. I'm very picky with my dovetail fittings, so I'll start with that. I didn't used to care much for layout lines before, but I'm finding them really helpful to speed up material removal. As long as I stay within those lines, I can continue to cut without the constant measuring. That looks really good. Next, I'll tackle the most critical feature, which is the slot for the tool. I want to have the tightest tolerance possible, while still allowing the tool to slide freely. The tool doesn't need to fully retract, but I'm still machining some clearance for that. So the fitting for the tool was carefully checked using this stack of gauge blocks. This is the exact same size as the shank of the tool. As soon as it started to bite, I stopped milling and began lapping with this diamond compound. The fit is as good as I could have hoped for. Finally, time for some holes. And this is obviously oversized on purpose. Let's set the tool holder aside for now and work on this new block. These will become the driving lever for the mechanism. The shape is not really that important, but there's a few things that must be right. First of all, the thinner it is, the more clearance I'll get at the bottom of the tool holder. So I'll skim this to 4 mm. That looks like a good compromise as the lever also needs to resist bending. Second, it needs to be long enough and have a sort of a tail sticking out of the tool holder. That's not only what will trigger the retraction, but also what I'll use to reset the tool. Finally, the holes. There's 2 of them, one for the pivot point and one for the linkage, which is not this one. This is to start shaping the tip. I'll finish that in a moment. And this is the hole for the linkage. It's basically an over-center mechanism. I'm betting you've heard of them. The linkage is really simple. It's just a little plate with 2 holes in it. That's it. I was about to set up the rotary table to finish it nicely with some round corners, but I guess I was too lazy. I took it to the grinder and then finished it by hand. It's good enough. All these rimmed holes are 8 mm, and obviously, I'm not going to use 8 mm screws for this tool. I'm going to use some M4s and M5s, but I didn't want the levers rotating directly against the threads. So 10 minutes at the lathe got me these brass bushings. And this is how the tool works. Now I can punch mark the location for the hole in the threading tool. For the cover, I got this piece of stainless. I like the brushed look, so I'll keep that, but machine the rest to size, including the back. I was going to use countersunk screws, but I changed my mind. I found a few of these low-profile screws, both black and stainless, and I'll use the stainless ones to match the cover. That means the positions I had marked for the screws will slightly change. I have this vise top that I never used before, and I thought it would be useful right now, but I just found out it's too big for my vise. I know I can use a parallel or something straight against the vise to work as a stop, but looking at these, I'm starting to think this was made to be machined to fit thinner jaws. With that sorted and my screws measured, I rest the tool holder against the stop. Then I try to edge fine and match one of the cutting edges of an 8mm end mill. From there, I can move the table by 1mm, as that's the maximum I can go and still find material to thread. Now I'll create the pockets for the screws on the cover. And yes, I'm going to plunge an end mill on 3/16 stainless. I'll do these for the 4 screws. Honestly, I don't know how this happened. I must have been sleeping or something. Now there's a portion of the threading tool sticking out past the tool holder. And the cover is getting in the way when the tool retracts. I can't just trim the tool because of the insert, and I can't mill a slot on the cover because the pocket for the first screw is in the way. So I guess the only alternative to save this cover is to machine both the tool and the cover. I'm not done with the milling on this cover yet. I still have to make a slot for the screw that holds the return spring. The problem with all these slots is deburring, and I admit it just looks acceptable. So after tapping the second hole for the spring on the shank of the threading tool, it's time to make a shim to fill this gap between the tool and the cover. At the moment, I don't have any material better than brass, and this was round bar, so yeah, a bit of a waste. To secure the shim, I'll use 2 screws. I was divided between M3 and M2.5, but the M3 has a bigger head to countersink, so M2.5 will be better. I just hope I don't break a tap after all this work. With these, all the parts for the tool are pretty much done. While there are a few types of retractable tools out there, this one is heavily inspired on Mr. Whoopi's tools. I'll link Mr. Whoopi's channel in the description below. There, you'll find several iterations of this tool in action. And the good part is that you can order one directly from the source and save yourself from all this nonsense I just went through. This was hitting my tool post, so I had to create some clearance. This notch kinda felt right. Then it was the tool holder itself, so I made this thread. I'll add a set screw to take all the punishment. Off camera, I just drilled and tapped this tiny hole, M2.5, and the reason why I did it was to add this little chip guard. This was designed following the contour of the threading tool, so that there's minimum clearance around it. Then I 3D printed it using a texture sheet, which reminded me of something I had for a while on the shelf. And by for a while, I mean, of course, 15 years. I know what you're probably gonna say, paint is not really a good finish for a lathe tool. And I totally agree. But once I saw the wrinkle tool holder in my head, I just had to try it. Besides, this is not a tool I use every day. Even for threading, I don't think I'm going to use it every time. So this should last for a while. And here is the result after cleaning up the edges. I don't know about you, but I really like it. Putting this tool together is really simple, you just need to follow the instructions. Although I recommend leaving the linkage free until the end, so you don't have to be fighting the spring. But during this process, I became very curious to see how this tool performs. Lathe tools need to be rigid, so I wonder how the fact that this is a sliding tool will affect its stability and overall performance. I also made these standoffs for the spring, otherwise it would start rubbing on the stainless cover. I rubbed some of the faces on sandpaper, just trying to clean them up a little bit, but I didn't go all the way to remove all the tool marks. My excuse is that I was starting to change dimensions and affecting how the parts fit together, which totally makes sense. The brass bushing for the main lever sits just a little bit proud, just enough to ensure that tightening the screw will not lock the lever. But with the tool holder painted, this top becomes even more important now. I thought I did, but at the moment I don't have any soft set screws. So let's head over to the lathe and modify what I have, which is a stainless set screw. I'll start by center drilling. This way, my 2.5mm drill will not wander. Next, the 2.9 drill will make the life easier for this 2.98 reamer. This piece of rod is 3mm, and if it doesn't fall off, it's good enough. I'll just cut a piece and press it in with the help of the tailstock. You can get these really cheap, and they're also available with plastic ends. It just happens that I've run out of them. I cut off a piece from an X key so I could adjust the screw from the other end, and also drive this other screw that will lock the first in place. I made this brass head so I could feed the ring from the other side, and I did this for a couple of reasons. First, the main lever will snap into position against this ring. That means the ring will probably wear over time. Since this is just a brass ring, it's easy for me to replace. Second, and more importantly, I'll use this ring's diameter to adjust the tool. What I mean is, if the tool locks solid, I'll make a smaller ring, but if it doesn't lock and jumps off easily, I'll make a bigger ring until the lever stays put. Basically, it's the easiest component to remake and the one that allows for more adjustment in the system. But I guess I got lucky, and I don't have to make any other rings. Chips. This is how they can get into the tool and jam the mechanism. It may not look like it, but this cover was a lot of work to get right. And I just hope it works. This is probably the best reason why I shouldn't be fully retracting the tool. Finally, the AXA height adjuster. I don't think I mentioned this was AXA size before. It is. And I have an M8 stud here for the height adjuster. I need a new wheel, but of course, I don't have any left and have to make one. And do you know what would be cool? If this tool was used to make it. So let's borrow the wheel from the part of tool I made last year, with the promise that this will be returned until the end of the video. 303 stainless. Knurling stainless by material compression is a real pain because it work hardens. So today I'll cut knurl these. Cut knurling produces a lot of tiny chips. Those need to be immediately removed from the knurling wheel to avoid unwanted marks in the knurling. So I'm going to use this Noga mini cool to blow those chips away. I think it's kind of obvious, but this was offered to me by KBC Tools Machinery, and I'd like to give them a big shout out and a word of appreciation. They reached out to me early this year as they wanted to contribute to the channel with some tools. But the thing is, they didn't push me to make videos. Instead, they told me to use the tools. Just use the tools. And if I did, if I could add the links to their website. So you know what you're going to find in the description. And I wasn't asked to do this, but I'm more than happy to tell you they were very cool during the entire process. And I'm really grateful to have a company that goes back 60 years helping my small overseas channel. Thank you, KBC. I truly appreciate what you did for me. Successful cut knurling starts with pressure knurling, using the edge of the wheel on the edge of the material. Then, when some depth of cut has been established, the power feed can be engaged to let the tool cut the knurl. Since this is stainless, a few passes are required to reveal the full knurl. It's not perfect by any means, but I think it looks crisp enough to continue. And that was definitely much faster than traditional knurling. Now to produce the square knurling effect, I'll make a thread over the knurling. So let's change to the correct set of gears and set up the auto-retract tool. I just finished this carriage stop. My lathe didn't came with one, and the threading tool needs to bump into something. So this was the perfect occasion to make one. And I was going to include the machining part in this video, but this is already getting long, and this stop had its own challenges. It totally deserves its own video. Don't worry, if you are subscribed to the channel, you'll be notified when I post it. All I can tell you right now is, if you've ever wondered if your carriage stop has the correct angle machined, this is how you can test it. But here's another challenge. The angle between two flanks of the knurling I just cut seems to be 120. This threading insert is 60 degrees. That's not going to give me the square knurling I want. So I looked online for a different insert for this tool, at least with 90 degrees. But I couldn't find anything, which kind of makes sense since this is a threading tool. So obviously, my next step was to make a couple of jigs to modify inserts. If you're wondering why there are two of them, it's because it was the simplest way I found to have access to both facets. While the first one was pretty easy, for the second, I couldn't get the right angle without having the machine hit the grinding wheel. So to speed things up, I made one of these jigs and then mirrored it. This way, I just need to flip the insert to grind it. I don't even need to change the angles on the machine. You can't really see anything different here, other than the grinding marks, but this facet changed from 30 to 45 degrees. And I did this for all three edges. Now I'll swap the jigs to grind the second facet. This went surprisingly well. But looking at these, I'd rather not have this boss next to the cutting edge. This actually looks like a leftover from the original grind, so I'll get rid of it. All of these went better than I expected, but one of the jigs is done. The carbide was getting really hot on this last step, where there was more material to remove, and the PETG didn't survive. Anyway, I got what I wanted from this. Here's an unmodified insert for comparison. I guess now it's more evident, the difference from 60 to 90 degrees. Back at the lathe, I now have everything to start threading. The pitch of the knurling wheel I used is 1.5 mm, so I'll be threading the same pitch. But before I start, I'm double checking all the clearances. Next, I'll set the tool on center. Of course, not forgetting to immediately break one of the cutting edges. Now I'm ready to go, and I'll go slow on this first try. It didn't occur to me, but threading on an knurled surface is producing these tiny, minuscule chips. Those are getting into the tool and start affecting the retraction, so I'll bring back the mini-cool for this last pass. I don't think this will happen with normal threading though, but we'll get there. And I think I'm done with this. I'm very happy. My lighting and the camera don't do it justice. And this was a great test too, as I didn't use the compound. I plunged the tool straight in, making interrupted cuts with both cutting edges on stainless. So nothing left to do but cut some rounds and tap these M8. Finish these adjusting wheels so we can try a real thread. Just for demonstration purposes, I remade the part I've shown you at the beginning of the video. And this time I'll add the thread before I cut it in half. I also changed chucks because this part is smaller and I'll be working closer to the chuck. And I'm worried if the lever is caught by one of the chuck jaws. In case you haven't noticed, I also cleaned up. I clean up a lot. Maybe I should spend the time making more stuff. And I think we have a problem. Let me make another pass. Yeah, there's something wrong. I don't know if you already spotted it, but the tool is cutting deeper during the retraction. That's evident right here. While the peaks seem to be at the same height, the valleys are not. And I can measure it with my micrometer too. When something like this happens, and it does happen, I feel the urge to immediately track down the issue. So never mind the 2 AM, this DTI doesn't get tired and shows exactly what's going on. The tool moves 5 thousandths forward before retracting. Now I just need to figure out why. I think it might be one of two things, or both at the same time. First, the lever has this raised edge. This obviously pushes the bushing forward as the tool disengages. I don't know how I let that one slip. Second, it might be the mechanism itself. But I'll start by fixing the lever, which I did with a file. I just want to see if it makes any difference. And to my surprise, it doesn't. Maybe 1,000? Anyway, it's not this. So it's got to be the lever's arrangement. I just got back from the mill, and besides drilling another hole on the lever, I also finished these with an end mill. And the problem seems to be fixed now. Turns out this shouldn't be an over-center mechanism. That's so obvious now. The rest position of the tool, under load, has to be the most forward possible in the system. And now I think all the holes should be in line. But I can't change that now unless I remake the main lever. It's now 4 AM, and I won't go to sleep until I see some good threads. So before I start making new parts, let's test these as is. If the tool retracts on its own, I'll have to make a new lever. I apologize, but I didn't remake that part I want to thread. Machining stuff on threading gears is painful enough, and this should be the same in terms of wall thickness. Let's see what this tool can do now. Look at the reflection of the light on the part. Looks perfect to me, don't you think? This was the last pass for this M20x1 thread. And my mic says it's good. Now I should go to sleep. Just to wrap things up and finish the video, this test piece has pretty much the same wall thickness as this section here. As you can see, there's not much material for a relief. So I think this tool is going to work. The knurling part was interesting as well. I really like how this looks different from the usual knurling. And I know someone's gonna ask this. I kept the half nut engaged during the video and reversed the lathe. In terms of auto disengaging the half nut, I may or may not do something about it. It depends on how much I need it. For now, I'll use these to make the parts I want, which you'll probably see in one of my next videos. Until then, happy holidays, have fun!